Hey, as we get set to launch RADx, Franklin is in the Science Operations Center. And Franklin, what's going on?
The mood is great in here in the Science Operations Center. It's actually standing room only. It's filling up. Everybody's getting ready for the filling of the balloons so that they can get RADx off the ground.
And talking about balloons, you know a little bit about balloons.
Yes, actually, over the summer, I rode up to the Wallops Flight Facility and talked to the chief of the Balloon Project Office about the balloons and how they'll actually get RADx off the ground. I'm here with Debbie Fairbrother, who is the chief of the NASA Balloon Program Office. How you doing, Debbie?
Hi, I'm great.
I was over at your lab earlier today, and I noticed that you had a couple of different balloons on display. You have the zero pressure and the super pressure balloon. Which one are you going to use for this experiment?
For this mission, we'll be flying on a zero pressure balloon.
What's the difference between the two?
The zero pressure balloon is a vented system, so it's basically zero differential pressure at the base of the balloon. A super pressure balloon is a pressurized system, much like your car tire. And the difference is, with a zero pressure balloon, if the sun goes down, the gases in the balloon cool, you're going to contract and you're going to lose altitude. In a super pressure balloon, as long as you're pressurized during the day, when the sun goes down, you're going to lose pressure. But as long as I maintain a positive differential pressure across the envelope, you'll float at the same constant density altitude.
Well, in this experiment, the balloon will have to go up and then come down during the course of the 24-hour period. Tell me a little bit about how that will be done.
Exactly. RADx is a little unique for us because they have basically two altitudes of target. They want to float at a high altitude during the day, and then at night they want to come down to a secondary altitude and stay stable at that altitude during the night. So it's a little bit different. We've had to do a lot of simulations. We're flying a balloon that has 3 valves on the top so that we can let off more gas quickly if we need to.
It's not like a hot air balloon, is it?
No. So our balloons are helium.
Okay, all right.
So we're not bringing any heat source to it, but they are heated by the sun.
Okay.
And the helium is our lift gas. How we fill it is we have inflation tubes, and in a zero pressure balloon, they go into the side wall of the balloon, so kind of through the shoulder of the balloon.
So it looks like the balloon has sleeves.
Yeah, I mean, so it's they're kind of dangling, and then at the end, one of the keys that you see in an inflation is the tubes are still attached and kind of rigid, you know you're still inflating.
Right.
If they've been, stopped inflation and tied it off and cut it away and they're just kind of hanging, you know you're close to launch.
So I'm assuming you have GPS on the payload and that's how you track it?
Right, so through the NASA Balloon Program and the Columbia Scientific Balloon Facility, we provide the command and control. So we have all of the electronics on board to know where the balloon is, as well as how to terminate it. So we've got all of the command and control of the mission.
So you mean terminate if it were to start moving toward like Mexico?
Right, and even at the end of the flight. So if it's going in a direction we don't want to, or when the science is over and we need to bring it down, we have that capability.
Venting.
Well, actually, no. To terminate, what we do is actually, it's fun. We actually send a command to separate the bottom of the balloon from the top of the parachute, which in turn rips a panel open in the balloon. So the payload will come down to the ground on the parachute, and the balloon will free fall. And we'll go and recover both items.
Is the balloon you're flying a weather balloon?
No. We're flying a scientific research balloon. Typically, a weather balloon will go up and pop. Oftentimes, they're made out of a latex material, so it'll go up, expand, and pop. Our balloons go up and float, and so typically the science is done once you reach the stable float altitude. So we often say a weather balloon goes up and pops, and the NASA balloons go up and stay a while.
So Franklin, with your experience with balloons down and interviewing Deb Fairbrother, give us your thoughts. I mean, this balloon looks, it's kind of hard to judge the size of the balloon on the screen, but it looks like it's a pretty big balloon from here.
Yes, actually, it really is. You guys had an opportunity. Hey, there it is.
Yeah, there we go. Wow, that's pretty impressive, isn't it?
Okay, see, that's what they mean by big. See, now you got to get back and see the whole thing. Oh, yeah, wow. Oh, that is awesome.
So now Big Bill is driving to make sure that it's in the right alignment before it releases.
Look at him go. There he goes. Awesome job.
And the folks from Fort Sumner from the Columbia Scientific Balloon Facility is offering this program feed right now for us. He's
there we go.
Operating the camera. There goes the balloon.
Look at that. See, now that gives you a better sense of the scale.
That's right.
How huge that is. Oh, lots of emotion in the room in there. Oh, look, oh, check it out. Sorry. Little enthusiasm there. There's the onboard camera. That's awesome.
This ends our broadcast for the Radiation Dosimetry Experiment, or RADx. I'm glad you had a chance to join us.
And we look forward to hearing from you guys. If you have questions, comments through Facebook and Twitter, either way, let us know. We'll try to get answers out to you guys. Not from us, don't worry. It'll be from
You're not going to answer the questions right now.